this video, we're going to look at finding the equation of a normal line. Now, if you've seen my video about finding the equation of a tangent line, that was a pretty straightforward process. And very similarly, so is finding the equation of a normal line. In fact, they're almost done the exact same way. They are done the exact same way up until you find the slope using the derivative at the point that you're given. So again, just real quick, for a tangent line, remember that tangent line goes very, very closely to that line, actually physically touches at that point A, and gives us, it follows the slope at that point A. A normal line is a perpendicular line to your tangent line. So if I found the normal line here at A, we would actually be taking the slope at A and using the opposite reciprocal. Remember, when we find a slope, we can take the opposite reciprocal to find a perpendicular line. And so we're going to get the line that is perpendicular to that point. And so that's all we're going to be looking at today. So we're going to take the derivative to find the slope at a given point. Then you're going to use point slope formula to create a linear equation utilizing y minus y1 equals m times x minus x1. But that m is where you have to use the opposite reciprocal. Otherwise, if you plug in the value of m, you get out of the derivative, you're going to be finding the tangent line. In order to find the normal line, you have to take the opposite reciprocal of your slope. All right, so let's see what that looks like. So this question asks us to find the line normal to the function f of x equals 6 over 4x squared plus 1 at the point -1, 6/5. Fair enough, straightforward question, just a quotient rule. F prime equals, well, low, so 4x squared plus 1 times the derivative of the high, well, that's 0, that's easy, minus high times the derivative of the denominator. Well, 4x squared plus 1 is just going to become 8x over 4x squared plus 1 squared. Now, we can simplify. We can clean up a little bit. So f prime of x equals negative 48x over 4x squared plus 1 squared. Now, again, at this point, when I plug in my x value, I'm going to find the slope at the point -1 and 6 over 5. I want to find the normal line, okay? So the normal line is going to use the opposite reciprocal slope. So let's go ahead and we're going to plug in -1 into our function. So we have negative 48 times -1 over 4 times -1 squared plus 1 all squared. That gives me a positive 48 over, well, 1 squared is 1 times 4 is 4 plus 1 is 5. 5 squared gives me 25. So this is the slope that I would want to use if I were creating a tangent line. We want to find the normal line, so I need to find and take the opposite reciprocal. Opposite meaning change the sign, reciprocal meaning flip your fraction. So now, at this point, what we can do is we can take our point slope formula, y minus y1 equals m x minus x1, and we can plug in our x value, our y value, and now our slope into the point slope formula, and we can get our normal line. So I have y minus 6 over 5 equals negative 25 over 48 times x minus x1. Go ahead and start simplifying this. So we get y minus 6 over 5 equals, make sure I'm not getting cut off here, negative 25 over 48 x plus, oh, I'm sorry, I didn't plug in here. I should have plugged in my -1, which is actually going to be +1. So when I multiply, obviously, -25/48 to the 1, we're going to get -25/48. And now I'm going to add 6/5 to both sides. And when that happens, we are going to wind up getting y equals -25x/48 plus, simplify that, it winds up being 163/240. Not the prettiest fraction by any means, but the normal line nonetheless. So again, when I am trying to find the normal line of a function, what I want to do is I want to take the derivative. Once I take the derivative, I'm going to plug in the point, the x value at the point that they give me, and that's going to give me my slope. Once I find my slope, if I'm looking for the tangent line, I use that slope. But since we're looking for the normal line, we use the opposite reciprocal and then plug it into our point slope formula. So I hope this video helped. Normal lines, tangent lines, all very easy once you get the hang of taking the derivative and utilizing point slope formula. Thanks for watching the video. I hope you guys enjoyed it. I'll see you guys next time.